Hello, it's Ms. DeLulo, and today we are going to factor quadratics when our a value is not equal to 1 to continue our goal of solving quadratic equations by factoring. In our last video, we used a series of steps in order to factor, and we are going to actually use those same exact steps even though our a value in this case might not be equal to 1. So let's start with our first problem. We have 4x squared plus 30x is equal to negative 50. In our first step, we need to write the quadratic equation in general form to make sure that we have it as ax squared plus bx plus c and then equal to f of x or 0. So in order to do that, I'm going to add 50 from the right and add it to the left-hand side. So now I have 4x squared plus 30x plus 50 is equal to 0. Since my equation is already equal to 0, I'm done with step 2 and can move on to step 3. If you can, you need to factor out a greatest common factor out of every single term. Now it's only a greatest common factor if it goes into each term. So in this case, 4, 30, and 50 are all even, and I know that they can all be divided by 2. That's the biggest number that goes into all three of those coefficients. So I'm going to bring my 2 out front and divide each coefficient by 2 and write what's left over. So 4x squared divided by 2 would be 2x squared. 30x divided by 2 is 15x. And 50 divided by 2 is plus 25. And set that equal to 0. Now notice that when I factored my 2 out front, I put brackets on the very outside instead of parentheses. Since I know that later I'm going to be factoring by grouping using parentheses, the brackets just help keep things more organized. So now I'm going to proceed with the next step, find two numbers whose product is a times c and sum is equal to the b term. So let's figure out what our a times c is. Our a term is 2 times our c term of positive 25. So we're looking for the product equal to 2 times 25, which is 50. Now we draw in our t-chart so we can add in the next column the sum of our b term, which is positive 15. So we're looking for the product of 50 and the sum of 15. So let's list our factors of 50. We have 1 and 50, negative 1 and negative 50, 2 and 25, negative 2 and negative 25, 5 times 10, negative 5 times negative 10, and then if I went all the way up, 6 through 9, there are no other factors of 50 until I get back to 10, so I would be back where I ended on my list. So now I can move over to adding these factors to get our sums. So we have 1 plus 50 is 51. Negative 1 plus negative 50 is negative 51. 2 plus 25 is 27. Negative 2 plus negative 25 is negative 27. 5 plus 10 is 15. And negative 5 plus negative 10 is negative 15. Since I'm looking for my sum to be positive, my winning factors will be 5 and 10. So now we go back and rewrite our original equation by replacing our b term 15x with our new factors. So I'm going to start with my 2 outside and then bracket and then my first term of the trinomial, 2x squared. Everything up until that point stays the same. Then we replace our b term with our two factors, so plus 5x plus 10x. And it doesn't matter which order these go in. You can have plus 10x plus 5x and you will arrive at the same answer. And our c term stays the same, plus 25, end my bracket and set that equal to 0. Now that I have 4 terms, I can factor by grouping. So I'm going to group my first 2 terms and then my last 2 terms, including the sign of this third term. That always includes with your second set of grouping symbols. So now I'm going to, again, keep my 2 in bracket out front, and this is why I have the bracket there, because now I have a bracket next to a parenthesis, and it just keeps things less confusing. So what can I factor out of 2x squared plus 5x? What do they both have in common? Well, I can't factor out a coefficient without getting a decimal, but I do know that they both have an x in common. So I can divide both of these terms by x. 2x squared divided by x will just be 2x, and 5x divided by x is just plus 5. So that is my first factor. What can I take out of my second set of parentheses? Well, in this case, I know that the number 5 can go into both 10x and 25. But I can't take out a variable because 25 does not have an x, so I'm going to be factoring out a positive 5. When I divide by positive 5, I'm left with 2x plus 5. And my bracket and set it equal to 0. Now at this point I can factor out another greatest common factor, which is that I have these both 2x plus 5s as factors. So I have my GCF out front, 2 times 2x plus 5, and then my remaining factor is x plus 5, set that equal to 0. At this point, I got rid of my brackets because now that everything is grouped off, I don't really need them anymore. So now we're going to carry through with the zero product property and set each factor equal to 0. So we have 2 is equal to 0, 2x plus 5 is equal to 0, and x plus 5 is equal to 0. Since each of these are equal to 0, let's solve. Well, starting with 2 cannot equal 0, so that's not going to be a solution for us. Moving on to 2x plus 5 equals 0, we can subtract 5 from both sides. So 2x is equal to negative 5, divide by 2, and x is equal to negative 5 over 2. And my third solution, we have subtract 5 from both sides, and x is equal to negative 5. So because the 2 does not equal 0, that does not count as a solution to this equation. So we have x is equal to negative 5 halves, or x is equal to negative 5. Let's try another example. So we have 2x squared plus 7x minus 4 is equal to f of x. In this case, I'll need to start by replacing my f of x with a 0. Now that I have my trinomial in general form equal to 0, I can multiply a times c, which is negative 8. So I'm looking for two numbers that have a product of negative 8 and a sum of my b term, which is 7. Let's list our factors of negative 8. When I add those factors, I have the following numbers. And now looking for my solution, I need the two numbers that multiply to negative 8 and add to positive 7, and that's my first pair. Negative 1 times 8 will add to equal positive 7. So now I start by rewriting my 0 equals 2x squared. Remember, the first term always stays the same. The only thing that changes is that I'll break up that b term into my two factors, minus 1x plus 8x, and that is equal to, or then minus 4, your c term, all equal to 0. Now that I have 4 terms, I can factor by grouping, group off my first two terms, and then the sign plus my second two terms. And now that I have everything grouped off, I can look to see what I can factor out of these sets of parentheses. So I have 0 equals, and in 2x squared minus 1x, they both contain an x, so I can divide by x, leaving me with 2x minus 1. In my second set of parentheses, I can bring out a positive 4. When I factor out a positive 4, I'm left with 2x minus 1. So my common factor here is 2x minus 1, and my remaining factor is x plus 4. Now I can set each of these equal to 0 by the zero product property, and then solve for x. So we have 2x is equal to 1, divide by 2. Our first solution, x is equal to 1/2. And our second solution, subtract 4 from both sides. So x is equal to negative 4. So our two solutions, x is equal to 1/2, and our second, x is equal to negative 4. In this last example, we are missing the b term, so I'm going to go ahead and rewrite this with a b term inserted inside. We have 4x squared plus 0x minus 9 is equal to 0. So now that I have my general form, I can start by using the AC method, and I'm looking for two numbers who have a product of negative 36 and a sum of that b term, which I added in, which is 0. So now I can list my factors of negative 36. There's a lot of them. And then finally add those factors to see which one bring us to a sum of 0, which would be negative 6 and positive 6. So I'm going to rewrite my expression. My a term stays the same. My b term changes to my two new factors. My c term stays the same and equal to 0. Now that I have four terms, I can use factoring by grouping. Out of my first set of terms, I can bring out a 2x. When I divide by 2x, I'm left with 2x minus 3. In my second set of terms, we have 6x minus 9, so I can factor out a positive 3 and be left with 2x minus 3 equal to 0. My common factor is 2x minus 3, and my leftover factor, 2x plus 3. By the zero product property, I can set these each equal to 0 and then solve for x. So my first solution, we have x is equal to 3 halves. And in my second solution, we have x is equal to negative 3 halves. Now, this is what we call a difference of two squares. We worked with these a little bit in the first video, but they're a little bit harder to recognize because you would have to square root both the first term and the second term. Now when I take the square root of 4x squared, I'm left with 2x. When I take the square root of 9, I'm left with 3. And then you just insert a plus or minus because you're taking the square root of each. So in this case, if you recognize a difference of two squares, you can go ahead and skip all the steps in between and bring it down to your two factors of your 2x minus 3 times 2x plus 3. And that is all. Go ahead and try the problems below and make sure that you write down any questions that you have.